I'm Anil Kumar. In this video, we'll review polynomial functions. This is part of curriculum of advanced functions, also O-level and IB math polynomials. We'll take up 10 questions as listed here. You can always pause the video, copy these questions. I hope you can see first 6. Now you can copy questions 7 to 10. Question number 10 is a bonus question where we'll explain a method to factor x to the power of 4 plus x squared plus 1. This is actually not factorable, but we'll see a technique of factoring it. Let us begin by answering these questions one by one. I would like you to take it as an exam review for pre-calculus course. Question number 1. Determine x-intercepts for the function f of x equals to minus 3x plus 1 to the power of 4 plus 48. So we are given the function f of x equals to minus 3x plus 1 to the power of 4 plus 48. Now if you want to find x-intercept, it means what? It means y equals to 0, which is f of x. So let's equate f of x equals to 0 and find what x is. So we get minus 3x plus 1 to the power of 4 plus 48. So we can now rearrange, take these terms to the left side. So we get 3x plus 1 to the power of 4 equals to 48. Divide by 3, you get x plus 1 to the power of 4 equals to 48 divided by 3, which is 16. Now you take the fourth root. So we get x plus 1 equals to fourth root of 16. Now whenever you do square root of fourth root, you have to take both plus and minus values. So what you get here is plus and minus 2. So x is equals to plus minus 2 minus 1. So get two solutions for this. One is plus 2 minus 1, which gives you 1. The other one as minus 2 minus 1, which is minus 3. So we get two x-intercepts. We can write these intercepts as x equals to 1 and minus 3. Right? Let's move on to question number 2 now. We need to factor b to the power of 4a minus 81 and x plus 3 whole cube plus 8. So there are two questions here. So let's call them part A and B. So A is to factor b to the power of 4a minus 81, and B is to factor x plus 3 whole cube plus 8. You can always pause the video, answer these questions, and then check with my solution. Now here we can do difference of squares. We could write this as b to the power of 2a plus 9 times b to the power of 2a minus 9, right? Difference of squares. Now, b to the power of 2a minus 9 can be further factored. So what we get here is b to the power of 2a plus 9 times b to the power of a plus 3 times b to the power of a minus 3. So basic rule which we have used here is x squared minus y squared could be written as x plus y times x minus y. Right? Now to factor x plus 3 whole cube plus 8, we could use the formula for, let me write a cube plus b cube formula, right? Which is a plus b times a squared minus ab plus b squared. So that will help us to straight away factor the given expression. So let's rewrite this as x plus 3 whole cube plus 8 could be written as 2 cube. Now A for us is x plus 3, b is 2. So we could write this as a plus b, which is x plus 3 plus 2 times square of x plus 3 minus product of these two. That means 2 times x plus 3. 2 times x plus 3. That's correct. Plus square of 2, right? Plus square of 2, which is 4. So let's expand and simplify. We get x plus 5 as 3 plus 2. And here, x plus 3 whole square means x square plus 2ab means 6x plus 3 square, which is 9. 2 times this will give minus 2x minus 6, and we have plus 4, which could be written as x plus 5 times, combine the like terms, x square, 4x for 6x minus 2x, and 9 minus 6 is 3 plus 4 is 7. So we get our answer as x plus 5 times x squared. So let's check if we can factor this. No, this cannot be further factored. So let's write down 4x plus 7 as our final solution, right? Question number 3. Write the quadratic function with zeros at minus 2, 0, 1, and 3, and f of 2 equals to 16. So the function could be written as 0 at minus 2 means the factor is x plus 2. 0 at 0 means x minus 0. X minus 1 for 1 and x minus 3 for 3. A times. So this was a family. To find a specific function, we'll write a. And now we are going to substitute the value 2 here. So we have f of 2 is equals to, substitute 2. So we get 2 plus 2. This is x, 2 minus 1, and 2 minus 3. That should be equal to 16. So we get 4a, this is 4, and we get x. I should have written 2 here for x, I'm sorry. So this is actually 2. So this is 2 times 2, so we get 2. 2 minus 1 is 1. 2 minus 3 is minus 1. Correct? Should be equals to 16. So 4 times 2, 8, minus 8 rather. So we get minus 8a equals to 16, or a equals to 16 over minus 8, which is minus 2. And therefore, the function f of x can be written as minus 2. Let's write this x first. So we get x plus 2 times x minus 1 times x minus 3. So that becomes the polynomial for the given roots. You can always verify that if you substitute 2 here, then we do get 16. So 2 times 2 is 4, 4 times 4, 16, and that is 2 minus 1 is 1, and this is also 1 minus, so that gives you plus 16. It's good to check. Question number 4. Polynomial 2x cubed plus kx squared minus 3x plus 18 has x minus 3 as one of its factor. What is the value of k? So we are given the polynomial, let's call it p of x, as equal to 2x cubed plus kx squared minus 3x plus 18. Now when we say that x minus 3 is a factor, it means what? It means that the value of the function at 3 should be equal to 0, right? So this value should be equal to 0. So let's substitute 3 here. So we get 2, 3 cubed plus k times 3 square minus 3 times 3 plus 18, right? So we get 0 equals to 3 cubed is 27. 27 times 2 is 54. We get plus 9k minus 9 plus 18, and now we can calculate the value of k. taking all these terms to the left side. So we get 54 with a negative sign plus 9 minus 8 equals to 9k, which is, calculate, 9 minus 8 minus 54 equals to minus 53, and we'll divide this by 9 to find the value of k. Divide by 9 equals to minus 5.88. So let's keep it minus 53 over 9. So we get our answer as k equals to minus 53 over 9. Question number 5. Given y equals to x cube plus kx square plus k minus 2k square x minus k square, show that x minus k is a factor. Determine other factors. Now this is a very interesting question. It has two parts. We have to show that x minus k is a factor. So that really means that in the given function, which is y equals to x cube plus kx square plus k minus 2k square within brackets x minus k square, we should get 0 for x equals to k. Only then x minus k is a factor. This is from remainder theorem, or you can say factor theorem. Okay, so let's substitute k for x. So what do we get? We get k cube plus k times k square plus k minus 2k square times k minus k square, right? So that gives you k cube plus k cube. Let's open this bracket. We get plus k square minus 2k cube and minus k square. So k cube plus k cube is 2k cube minus 2k cube is 0, and k square minus k square is also 0. So that shows that x minus k is a factor, correct? So we have shown that, so therefore x minus k is a factor, correct? Now let's find the other factor, which is part 2 of this question. So we can do long division to find the other factor. We'll divide the expression x cube plus kx square plus, let me write this as kx minus 2 k square x minus k square. We are going to divide this by x minus k, right? So the first two terms we have to divide. Quotient will be x square. We get x cube minus kx square. So when you take away, you get 2kx square. Bring down the x terms, which is plus kx minus 2k square x. Now, so in this particular case, as you can see, we have 2kx squared. Therefore, we are going to multiply by 2k. So we get 2k times. So when you multiply by 2k, you get 2kx. So it becomes x squared. Multiplying minus k with 2kx, we get minus 2k square x. And now we'll take away. So when you take away, 2k square x, 2kx cancel, and we are left with kx here. And from there, we are going to bring down minus k square. Now it goes k times. So plus k will give us kx minus k square. The remainder is 0. That means the other factor is x square plus 2kx plus k. Is that clear? So we found the other factor. So we can write our answer as y equals 2. We know one of the factors is x minus k. The other factor is the quotient x squared plus 2kx plus k, right? So that is how you're going to solve this particular question. So I hope the steps are absolutely clear. Now let's take up question number 6. We are almost in the middle. Question 6 is, if 2 times x to the power of n plus ax squared minus 6 has remainder of minus 7 when divided by x minus 1. It means if this is our polynomial function p of x, in that case when we divide by x minus 1, that means p of 1 is equal to the remainder minus 7. That is the remainder theorem, right? And the remainder of 129 when it is divided by x plus 3. That means p of minus 3 is equals to 129. Find a and n. So these are the two unknowns which we need to find. Now both these conditions will give us two equations. So if I substitute 1 here, I should get minus 7. So let me write down the equations. The first one will be minus 7 equals to 2x to the power of 1 plus a, x is 1 for us, right? X squared minus 6, we are substituting x equals to 1, so it becomes minus 7 equals to 2, n, right? Plus a minus 6, or you can rearrange this and write down minus 7 plus 6 minus 2 equals to a. So that means a is equals to minus 9 plus 6, which is minus 3. So a is minus 3 for us. Now let us substitute minus 3 and get the other equation. So when I substitute minus 3, we get p of minus 3 equals to 129, which should be equals to 2 times minus 3 to the power of n plus a. A is minus 3. So I'm substituting minus 3 for this value of a, right? X squared, x is also minus 3 squared, minus 6. So this is our second equation, where the only unknown is n. Now we can easily find n, right? So we get 129 minus 6, let's bring it to this side. So we get plus 6. Now here we have 2 times minus 3 to the power of n. Minus 3 squared is 9. 9 times 3 is 27. So we have minus 27 here. So let's rearrange. So we have 129 plus 6 plus 27 equals to 2 times minus 3 to the power of n. So let's calculate. 129 plus 6 plus 27 is indeed equals to 162. So we get 162 equals to 2 times minus 3 to the power of n. So if I divide, let's take it to this side. So we get 162 divided by 2 equals to minus 3 to the power of n. Now that is 81 equals to minus 3 to the power of n. Now 81 is 3 to the power of 4, or minus 3 to the power of 4 is also 81. So we get minus 3 to the power of n. That means 4 is equals to n. So we get our answer, which is n equals to 4 and a equals to minus 3. Correct? So that is how you could actually solve this question. It is a very interesting question. I'd like you to go through this once again, understand, and then move forward. Question number 7. The dimensions of a box are 4 times 5 times 6 If each dimension is decreased by x centimeters, find the polynomial to represent the decrease in volume. So original volume, we can say V1, is 4 times 5 times 6, which is 20 times 6 or 120. Decreased by 6 means the second volume. Decreased volume will be 4 minus x times 5 minus x times 6 minus x. Decreased by x, that becomes the volume. Well, the units are centimeter cube, since we have mentioned centimeter for x. So let's find what this is. So we'll just expand. Multiply the first two terms. 4 times 5 is 20, minus 4x, then minus 5x plus x squared times 6 minus x. That gives you 20 minus 9x plus x squared times 6 minus x. So let's multiply by 6 now. So 6 times 20 is 120 minus 54x plus 6x squared. Multiplying by minus x gives us minus 20x plus 9x squared minus x cubed. So that becomes the function. Let's combine the like terms. We get minus x cubed, x squared terms, 9 and 6 gives us 15, so plus 15x squared. The x terms are minus 54 and 20, which is 74x, and the constant is 120. The difference in volume is V2 minus V1, so which is minus x cubed plus 15x squared minus 74x plus 120, and V1 is 120. Take away 120. So we are left with all these three terms. We can take away x as common. Let's take minus x common. We get x squared plus 15x minus 74 as the factored form. That's our final answer. So the polynomial which represents the difference is shown here. Okay. We are almost at the end. Here is question number 8. Graph the function f of x equals to x squared minus 1 times x plus 2 whole square times 3 minus x whole cube. Now it is important to factor it completely and properly arranged before we graph. You will notice that x squared minus 1 can be factored. So let me do that. We get x plus 1 times x minus 1. And then we have x plus 2 whole square. Now this term is 3 minus x. It is a good practice to write it as x minus 3. Now of course you have to take negative outside. It's a cube, right? So negative cube will be a negative number. So you get this negative. So it is very important to understand that the factor, which is 3 minus x whole cube, could be written as minus of x minus 3 whole cube, and that is minus of x minus 3 whole cube. So this negative is shown here, and here we have got x minus 3 whole cube. It is the most critical step in this particular question. Now we know that the leading coefficient is negative. The degree of the polynomial is what? Let's figure it out and let's sketch. Okay, let's first analyze it in more details. So let's write down the degree first. Degree of the polynomial is 3, 4, 5, 6 and 1, 7. So degree is 7. You could do from here also 3, 4, 5, 6 and 7. Don't count 1. It's 2, right? So degree is 7. What is the leading coefficient? Leading coefficient is negative. Now, if that is the case, then you can decide what end behavior is, right? So in that case, the end behavior should be equal to, so whenever the leading coefficient is negative, right side of the polynomial function will be down, right down. Since it is odd, opposite ends, right? So we have right down. That is to say, when x approaches infinity, y approaches negative infinity. And the other is opposite ends. That is to say, when x approaches negative infinity, y approaches positive infinity, opposite ends. Is that clear? So that gives you the end behavior. Now let's look into zeros. So as far as the zeros are concerned, we have a 0 at -1, then we have 0 at +1, then at -2, and this one is at +3. Each 0 has a multiplicity. So this order is 1, this order is also 1. This 0 is quadratic in nature, it will turn, and here it is cubic in nature. So that is the multiplicity. Now let's mark these zeros. So let us say this is our -1. Now we know the end behavior is like this. -2, this is -2. Then we have +1, and let's say +3 is here. So for the quartic equation, we have these four, for heptic, this is 7. For heptic equation, we have these 4 zeros. Now -2, is of order 2, so the graph of the function will actually turn at this point, right? So it will kind of turn. We are coming from this side, it will turn back. At -1 it is linear, so it's going to cross. At 1 also it is linear, and at 3 it's kind of cubic, so it's going to go like this. Do you see that? So that is how it is going to go. So let's connect our points and draw the function. Do you see how? So that is how you could actually sketch your polynomial. So I hope it is absolutely clear. Now some of you could write characteristics of this polynomial, behavior, and all other things. One important criteria is also to mention what is the y-intercept. We have already mentioned all the x-intercepts. So for y-intercept, we can calculate for x equals to 0. So that is f of 0 is equal to what? So if I substitute 0 here, I get minus, this is this minus, then 1 minus 1, 1 times -1 times 2 square times -3 cube, right? So that is what we get. So minus and minus makes it positive, this minus makes it negative. 4 times 3 cube, so we get 4 times 3 cube is 27, right? So that becomes the y-intercept, which is equal to minus 4 times 7 is 28, 2, 4 times 2 is 8, 108, right? So minus 108 becomes the y-intercept for the given case. So I hope it is absolutely clear how to sketch a polynomial. You need to consider the end behavior from leading coefficient and the degree. Odd degree, leading coefficient negative, right side down, left side towards quadrant 2. So the graph moves from quadrant 2 to quadrant 4 with zeros at -2, -1, 1 and 3. 0 at -2 is quadratic in nature, multiplicity 2, it turns. At plus and -1 it is linear, and at 3 it is cubic, right? So with that, let's move on to the second last question, which is we need to write y to the power of 12 minus 1 as product of exactly 4 factors. So let's do this. Y to the power of 12 minus 1. We could think about this as, think like this, y to the power of 6 square minus 1 square. So we can use difference of square. So we could write this as y to the power of 6 plus 1 times y to the power of 6 minus 1. Now, y to the power of 6 minus 1 could be treated as difference of squares. And we could write this as y cubed plus 1 times y cubed minus 1. Now in this particular case, since you want exactly 4 factors, now y to the power of 6 plus 1 is the first factor. Both of them can be factored actually. You see that? Both of them can be factored. So what we could also do here is we'll kind of get into an alternate approach. So let me, because now we get 5 factors, right? So 2 of each. So what we will do here is we'll do difference of cube first. So let me go from here and write this as equals to y to the power of 6 plus 1 times. Think about this as a difference of cube. So like this. Think like this. Y square cube minus 1. Is it okay? 1 cube. So in that case, I could write this as y to the power of 6 plus 1 times difference of cube, right? So we get y square minus 1 times. Now this could be written as a square, which is y to the power of 4, plus ab, which is y square, plus b square, which is 1. So we got 3 factors, and now we'll factor y square minus 1. So we get y to the power of 6 plus 1 times y plus 1 times y minus 1 times y to the power of 4 plus y square plus 1. Do you see that? So that is how we'll factor it in 4. If I would have continued here, I could actually factor both of them. You get an idea, right? So we get actually more factors, right? So here I could have got y plus 1 times y square minus y plus 1, and this also gets factored. So I could have written this as y minus 1 times y square plus y plus 1. So the required solution here definitely is the second part, this case. So this is the required solution, right? Now that brings us to a very interesting question. You have observed here that we have something like y to the power of 4 plus y square plus 1, which cannot be factored. However, on the left side, you found that somehow this could be factored, right? So based on this, we have taken question number 10. It's a very interesting question. We'll actually factor something which is unfactorable. So we explain a method to factor. We have x to the power of 4 plus x square plus 1. Now the technique to do factoring of this is kind of like this. Think about this. If I have a plus b whole square, I could write this as a square plus 2ab plus b square, right? That is how I could do. If I replace a square by a by x square, I could also get this as x to the power of 4 plus 2 times x square b, and I could write this as replacing x with x square, I could write this as b square. So in a way, you can see I could factor this equation also. The only thing which I need here is 2x square, right? So I could write this expression as x to the power of 4 plus x square plus 1. I could add and subtract x square. You get an idea. So if I do this, then I can write this as x to the power of 4 plus 2x square plus 1 minus x square. So what I did was I introduced this, combined these two x squares to get 2x squares. Now these three terms can be factored. right? These three terms could be written as x square plus 1 whole square, right? If you expand, you get x to the power of 4 plus 2x square plus 1, correct? So these three terms can be written as this, a perfect square, and then we have x square. Now we could adopt difference of squares, right? For example, a square minus b square is equals to a plus b times a minus b, right? So this difference of square could be written as a is x square plus 1 for us, and b is x, so plus x, times x square plus 1 minus x. Just rearrange this. So we get x square plus x plus 1 times x square minus x plus 1. Do you get an idea? So we have factored unfactorable. So I hope you understand and appreciate why in the previous case we had a condition that we could have got 4 factors or 5 factors. Does make sense to you? Perfect. I hope you learned a lot in this. We'll actually do part 3, 4, and 5 to complete review, exam review on advanced functions. And I hope that's going to help you. So in this particular section, we concentrated more on polynomials. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thank you, and all the best.